Now, here is a very important component, a very important measuring equipment in the process industry, and it is called the pressure switch. We can also have the temperature switch, but this is the pressure switch. Now, what is the use of a pressure switch in the process industry? A pressure switch helps to measure the pressure of a process line. It helps to measure the pressure of a process line or process equipment. Now, you see the connection of this pressure switch. Now, the pressure of this equipment, of this process line, according to this equipment, is 0.02 millibar. 0.02 millibar. Now, it measures the pressure of this process line or the process equipment. This is the process line. Now, it can also be called the local pressure. The local pressure, you can also say it measures the local pressure of the process line. Now, it is local because you can take the reading on the feed, directly on the feed. No any other equipment added, just this as it is now. So it's local. Now, this now leads me to what they call the pressure transmitter. The pressure transmitter. Now, this is a pressure transmitter, the counterpart of a pressure switch. This is a pressure transmitter. Now, in this transmitter, you can see that there are no values on it. So there is no physical. You can't see any value to measure here. And why? Because this pressure transmitter is connected to the DCS. The DCS is called the distributed control system that measures the results of this pressure transmitter. So this pressure transmitter transmits the result, the pressure reading of this process line, down directly to the what? To the distributed control system, the DCS. Now, on the DCS, the reading of the pressure is read. It's measured instead of measuring it or reading it directly online on the spot or on the field. Pressure switch, on the other hand, measures the pressure on the field, whereas pressure transmitter measures the pressure or reads the pressure and sends it to the distributed control system DCS, and it is read on the monitor in the control room. Now, this is the connection that the wire or the cables that measures, that transmits the temperature, the reading, which is the pressure, down to the distributed control system, where it is taken, where it is read and recorded on the spot. Now, this, if you look at the connection of this pressure switch, of this pressure transmitter and the pressure switch, you see they are connected on the same process line. They are connected on the same process line. Now, why do we need the two on the same process line, although on slightly different position? Why do we need the two on the same process line? Now, the reason is because an equipment, one of them may go faulty and the other serves as a standby. That is one reason. Then the other reason is so as to measure the results, or to compare the results of the two against one another, and then help to detect whether there is fault, if there is fault in any of the two equipment, in any of the two devices. So the primary reason why the two of them are used on the same process equipment is in case one gets faulty, the other can be used. And then this one is automated, is the automated form of this. This one is manual, it's read on the spot, it's measured on the spot, on the field, while this one transmits the results to the DCS, which is automated. So with this, you can read the results of you can get the pressure condition of this process line without coming to the field. But in this case, you will need to come to the field to get the measurement. You see, those are the two differences. In this case, you don't need to come to the field to get the measurement. You can easily get the measurement in the control room, wherever the control room is. and can be controlled from there. The pressure can be controlled from there depending on how it is designed. But in this case, we need to come to the field and get the actual reading on the field. This is not automated. This is not automated, and that is why it's called local pressure. Local pressure, as it is called, and the device again is called the pressure switch. Now, if you check the result of the two, the pressure transmitter and the pressure switch, the pressure transmitter on the DCS and the pressure switch on the field, you realize that the two measurements are not exactly the same. The two measurements are not exactly the same, and they are not expected to be the same. Why? The reason is because the points of connection on the process line are not exactly on the same spot. You see, one is directly on top of the other, so they are not exactly on the same spot. So the pressure difference is what results in the difference in the measurements of the pressure transmitter and the pressure switch. Thank you very much.